Hello students, welcome back to RD Chemistry. Here we'll discuss one small topic from states of matter, that is the Boyles Law. According to Boyles Law, the volume of the given mass of the gas is inversely proportional to its pressure at a constant temperature, or V is equal to one constant K divided by P, or PV is equal to constant K. Remember, at constant K, pressure into volume is always a constant. Initially, let it be P1 V1. For the same gas, if it is changed to P2 V2, then P1 V1 is equal to P2 V2 at a given at a constant temperature. Okay. Here we speak about the pressure and volume. Now, if I speak about the pressure, remember 1 atmosphere is equal to 760 mm of mercury, which is also equal to 760 in terms of torque, or 76 centimeter in the mercury column, or it is also equal to 1.013 bar, or 1.013 and 1 bar is equal to 10 power 5 pascals, and pascals are nothing but Newton per meter square, the SI unit. In terms of volume, if I go for 1 liter, 1 liter is equal to 1000 ml, or is equal to 1000 cm cube. Remember, ml and cm cube are one and the same. Or is equal to 10 to the power minus 3 instead of in terms of liters. Or 1 liter is also equal to 1 dm cube, decimeter cube. Now we'll see some graphs on Boyle's law. We know that V is inversely proportional to pressure, or I can also write down P is inversely proportional to the volume. So I'll draw the graph, pressure and the volume. Since they are inversely proportional, we are going to get a exponential like this, a curve like this. Okay. Now what I'll do, I'll plot pressure versus 1 by V directly. If I do that, pressure versus 1 by V, they are directly proportional. So we'll get a straight line like this. Okay. Now I want to plot PV versus the volume term. PV versus the volume term. Whatever the volume, PV is equal to always a constant. Whatever the volume, pressure into volume is always a constant. Whatever the volume, PV is always a constant. Same number, same value, is a straight line parallel to the x-axis. Now let me plot P versus V and P versus 1 by V for different temperatures. Okay. Now let me take the graph, pressure versus volume. Initially for one of the temperature, okay, say let it be T1 is equal to say some around 200 Kelvin. I'll go for higher temperature. I want to go for 400 Kelvin. Then I'll go for 600 Kelvin. Where will be the graph? Above this or below this? Now for that, let me fix the volume. For this volume, if I fix it, this is the pressure. This was the pressure. I'll increase the temperature. Volume of is same, but pressure will increase. Pressure has to increase somewhat like this. So I get a curve like this. Okay. Say this is at T2 200 400 Kelvin. I'll go for one more graph. Okay. And this is T3, that will be equal to 600 Kelvin. Remember, T3 greater than T2 greater than T1. Okay, fine. Now we'll go for one more curve. That is the P versus 1 by V. Already I've plotted P versus 1 by V. We'll get a straight line. Say this is the T1 is equal to say 200 Kelvin. I'll increase the temperature. Where will be the next straight line? Above this or below this? For that, let me fix the volume. When I fix the volume, 1 by V is also fixed, like somewhere here. For this 1 by V, this is the pressure. I will increase the temperature, but we'll keep the volume same. And keep the volume same, increase the temperature, pressure increase. The pressure should be more than this. So I'll get a straight line like this. Okay. So T2, let it be equal to 400 Kelvin. If I go for 600, next curve will be like here. Okay. So T3 is equal to 600 Kelvin. So T3 greater than T2 greater than T1. Fine. We'll see one question here. 103 ml of carbon dioxide were collected at 27 degrees centigrade and 763 mm of pressure. What will be its volume if the pressure is changed to 721 mm at the same temperature when there are many gas laws? To identify those gas laws, we'll have to remember the constant parameter. Same temperature. Same temperature, constant temperature means it should be Boyles law. Okay. If this is a Boyles law, there are two different types of pressure and volume. It should be P1 V1 is equal to P2 V2 at constant temperature. Okay. This should be at constant temperature. Fine. Now here they are given ml and they are given in terms of pressure mm. We need not convert these. If the temperature involved in the calculation, temperature must be changed to Kelvin scale. Otherwise, it is not required. So, initial pressure is equal to, given in the first line, first data, 763 mm of mercury. And the corresponding volume also has been given. So, let it be V1 is equal to 103 ml wise. Now, pressure is changed to 721 mm of mercury and they're asking for what is the volume. Now for this 763 103, for 721 what is the volume? Since they are inversely proportional to each other and the pressure is reduced, volume has to be increased, right? It should be more than 103. So therefore P1 763 into V1 103 is equal to P2 721 into volume V2 you have to calculate. Therefore V2 is equal to 763 into 103 divided by 721. So this is approximately equal to 109 ml comes. Okay, fine. Like the videos, share and subscribe RD Chemistry. Thank you for watching. Have a nice day.